Okay, we're starting notes today for compound probability. We're going to talk about mutually exclusive versus overlapping probability. This is still pretty similar to what we've been doing. We're just kind of putting names with some of these things now. All right, so we're going to talk about what mutually exclusive means first. So we have like a little example to think about this. Suppose we have a bag of 3 red marbles, 5 blue, 7 green marbles. What is the probability that you select a blue or a red marble? Now we've already been talking about this, but we're going to talk today about whether or not these things are mutually exclusive or overlapping. So, is it possible for us to pull a marble out of this bag and for it to be both red and blue? Can both of these outcomes occur at the same time? Absolutely not. We can't pull a marble out of the bag and have it both be red and blue. It's either going to be red or blue. So why or why not? Well, marble cannot be both red and blue. All right. And that's called mutually exclusive events. Sometimes it's called disjoint events as well. And basically what it means is it's 2 or more events that cannot occur at the same time. So it was not possible to pull a marble out and have it both be red and blue. The probability of the probability of 2 mutually exclusive events occurring at the same time is 0. There was no chance that we could pull out a marble and have it both be red and blue. To find the probability of one of the 2 mutually exclusive events occurring, use the following formula. This is kind of a yucky formula. Basically, you're finding the probability of finding one event plus the probability of the other event, and you want to subtract out the overlap. This is overlap right here. This is the intersection of A and B. But in mutually exclusive events, we don't have any overlap. So if I wanted to, if we're going to go back and actually solve this problem, find the probability of selecting a blue or red marble, well, our probability would be the probability of pulling a red plus our probability of pulling a blue. And then we would want to subtract out the overlap. So probability of red and blue. Well, our probability of pulling a red was 3 out of 15. We had 15 marbles, and we had 3 that were red. Our probability of pulling a blue marble was 5 out of 15. And then we would want to subtract out the overlap. Well, in mutually exclusive events, there is no overlap. There is no marble that is both red and blue. So we would just say minus 0 over 15. If you add these together, 3 over 15 plus 5 over 15 minus 0 over 15, we would get 8 over 15. That's our probability of picking a marble that is red or blue. But it can't be both. So we have another example of a mutually exclusive event right here. Suppose if you randomly chose one of the integers between 1 and 10, what is the probability of choosing either an odd number or an even number? Are these mutually exclusive events? Why or why not? Yes, they absolutely are. A number can't be even and odd. So they are mutually exclusive. We can't pull a number and have it both be even and odd. So yes, a number cannot be even and odd. It's not possible. So if we wanted to find the probability of pulling an odd or an even number, we would sort of use this formula that we were talking about before. But again, there's not going to be any overlap here. There's no numbers that are both even and odd. So we would find the probability of finding an even, plus we would add on the probability of finding an odd. And we'd want to subtract out the probability of both even and odd. So if we fill this in with numbers, the probability of finding the even, well, let's see here. How many numbers are even between 1 and 10? So let's actually write this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many even numbers do we have? We have 5 even numbers, 2, 4, 6, 8, and 10. So we have a 5 out of 10 chance of pulling an even number. Okay, what are the chances of pulling an odd number? Well, there are 5 odd numbers, 1, 3, 5, 7, and 9. So we have a 5 out of 10 chance of pulling an odd number. We'd want to subtract out the amount of numbers that are both even and odd. Well, that's not a thing here. So there are 0 numbers out of the 10 that are both even and odd. And then you want to sort of calculate this out. 5 over 10 plus 5 over 10. When you add fractions, you add the numerators together if they have the same denominator. So 5 plus 5 is 10. And then 10 minus 0 is 10. So we end up with 10 over 10, which is 1 or 100%. There's a 100% chance that we're going to pull an even or an odd number. So does this make sense? Yeah. All these numbers are even or odd. Are either even or odd. Okay, one more example of a mutually exclusive event. We have a 6-sided die and we roll it. What is the probability of rolling an even number or a 3? Okay, so in a 6-sided die, the outcomes are either going to be 1, 2, 3, 4, 5, or 6. So are these events mutually exclusive? Is it possible to roll a number that is both even and a 3? Well, no, 3 is not an even number. So are these events mutually exclusive? Yes. We can't roll both an even number and a 3. They are mutually exclusive. So now if we use the formula, find the probability of rolling an even number or a 3, the probability of rolling an even number is 3 out of 6. We have 3 even numbers, 2, 4, and 6. The probability of rolling a 3 is 1 out of 6. Don't say 3 out of 6. The probability of rolling a 3, we have 1 3 out of 6 options. So that's a 1 out of 6 chance of rolling a 3. And then we want to subtract out the probability of rolling an even number and a 3. That does not exist. So we want to add and subtract these fractions. 3 over 6 plus 1 over 6 is 4 over 6. And 4 over 6 minus 0 over 6 is just 4 over 6. If you want to reduce that fraction to 2/3, go for it. But you have a 4 out of 6 chance of drawing a even or rolling an even number or a 3. Okay. So let's get to the back. This is going to be mutually inclusive events, also known as overlapping. So I'm going to sort of write that right here. The mutually inclusive events, I'm going to put overlapping right next to it. This is going to be when we have sort of two things happen, but you know, you could have both things happen at the same time. So an example of that would be this. Suppose we are rolling a 6-sided die. So we're still rolling this die. And the die has 6 numbers. 1, 2, 3, 4, 5, 6. What is the probability that you roll an odd number or a number less than 4? Can these both occur at the same time? Yes, it absolutely can. What are numbers that are odd and also less than 4? Well, that's going to be 1 and 3. So 1 and 3 are both numbers that we could roll the die and have it both be an odd number and be a number less than 4. So mutually inclusive events, also known as joint events or overlapping, which I wrote up here, is when 2 or more events that can occur at the same time. We're going to use the exact same formula, only this time this overlapping part is not going to be 0 over a number. It's going to actually be a number because we have an overlap with both of these events. So we're actually going to, we're not going to solve this one out. We're going to move on to a different example. And let's talk about number 3. So what is the probability of choosing a number from 1 to 10 that is less than 5 or drawing an odd number? Okay, so I'm going to write our numbers out real quick. So all numbers less than 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are all the numbers between 1 and 10. All right, so we want to find what is the probability of choosing a number that is less than 5 or an odd number. All right, so what's the so this first one, find the probability of a number less than 5. We're going to want to find the probability of an odd number as well. And then we want to subtract out the probability of finding a number that is less than 5 and also an odd number. These exist this time. All right, so what is the probability of pulling a number less than 5? Well, how many numbers are less than 5 here? We have 1, 2, 3, 4. 4 of these numbers are less than 5. There are 10 numbers total, so we have a 4 out of 10 chance of pulling a number that is less than 5. How many odd numbers do we have? 1, 3, 5, 7, 9. That's 5 odd numbers out of the 10 possible numbers. So 4 out of 10 for less than 5, 5 out of 10 chance for it being odd. But then we have to subtract out the overlap. Okay, how many numbers are less than 5 and odd? Well, 1 and 3 are both less than 5 and odd. So we're going to subtract out 2 out of 10. There are 2 numbers out of the 10 that are less than 5 and odd, and that's going to get rid of this overlap. We don't want to count these 2 numbers twice, which is why we're subtracting it out. Okay, now we got to sort of figure this out. This 4 over 10 plus 5 over 10 minus 2 over 10, you're really just working with the tops here. 4 plus 5 is 9, and 9 minus 2 is 7, and that's going to go over 10. And that's our answer. We have a 7 out of 10 chance, or 70% chance, of picking a number that is less than 5 or an odd number. All right, we got sort of 2 more examples here. If you ever want to hit pause and try it on your own and then see if you got it by listening to me, that's not a bad idea. We got a bag here, contains 26 tiles with a letter on each, 1 tile for each letter of the alphabet. What is the probability of reaching into the bag and randomly choosing a tile with one of the first 6 letters of the alphabet on it, or randomly choosing a tile with a vowel on it? All right, this is mutually inclusive. This is going to have some overlap. The first 6 letters of the alphabet are A, B, C, D, E, F. So we have 2 letters. We have 2 letters that are vowels in the first 6 letters of the alphabet. All right, so we're going to set this up. We're going to do a probability. We're going to do this formula that we had up here. So I'm going to say this. The probability of picking a number in the first 6 letters of the alphabet plus the probability of picking a vowel, and we're not including Y in the vowels, and then we're going to subtract out the probability of a letter being in the first 6 and it also being a vowel. So what are our chances of pulling a letter? If we have 26 sort of letters in a bag, maybe you're playing Scrabble, and you pick one out, what is the probability that it's going to be one of these first 6 letters? Well, if we have just enough tiles for each letter, we have a 6 out of 26 chance of pulling that. What is the probability of pulling a vowel? Well, there are 5 vowels, so we have a 5 out of 26 chance. There are 5 vowels out of the 26 letters. And then we want to subtract out the probability of pulling, or like, what is the probability of a letter, pulling out both a letter in the first 6 and a vowel. Basically, we want to count all the overlap. There are 2 vowels in the first 6, so there is a 2 out of 26 chance that the letter we pull is both going to be in the first 6 and a vowel. Then we just got to work this out. You're really just working with the tops here. 6 plus 5 is 11, and 11 minus 2 is 9. So we have a 9 out of 26 chance of pulling a letter that's in the first 6 letters of the alphabet or a vowel. All right, last one. We got one of these Venn diagrams. Below is a Venn diagram of office workers who prefer to drink coffee and or water. Find the probability that a person will drink coffee or water. Okay, we're going to let the coffee be circle A, and we're going to let the water be circle B. And we're going to use this sort of formula. We're going to find the probability of someone who drinks coffee. We're going to add that to the probability of people who drink water. And then we're going to subtract out the probability of people who drink coffee and water. I'm running out of space. I'm going to say H2O. All right. So, what is the probability that you drink coffee? Coffee is the circle A. Okay, we got to do a little bit of work here. How many people are even in this survey? So don't forget about our Venn diagrams. It looks like we have 31 people who only drink coffee, 12 people who drink coffee and water, 25 people who only drink water, and then 83 people who apparently don't drink either. Or maybe they don't have a preference. I mean, you have to drink water, right? So how many people is that total? 31 plus 12 plus 25 plus 83. Looks like that's going to be 151. So we have 151 people total. All right. So what is our probability of picking a person at random and having them drink coffee? All right. Don't say 31. There are actually 31 plus 12. There are 43 people out of the 151 people who drink coffee and water. What is the probability of picking someone that drinks water? Well, don't say 25. There's 12 people who drink water and coffee. So 12 plus 25, that's 37. We have 37 people out of 151 that drink water. And then we got to subtract out the overlap. That's this 12 people right here. There are 12 people who drink coffee and water. So we're going to subtract out 12 over 151. Then we just want to work this out. You're only working with the tops. Probably want to use a calculator. 43 plus 37 minus 12 is going to be 68 out of the 151. That's how many people we have. That's the probability of picking someone that drinks coffee or water. Although this is a ridiculous question. Everyone should be drinking water. What is going on at this company? All right, that ends the notes for today. Make sure you go on and take your daily quiz for today. And email me if you have any questions.